Hello dear students, I am Sumitra Shrava, TGT Science, KVS RO, Delhi. Today we are going to learn a very important and interesting chapter, that is Structure of the Atom, Chapter 4 of Science. Topics that will be covered in today's session are charged particles in matter, the structure of an atom, Thomson's model of an atom, Rutherford's model of an atom, Bohr's model of an atom. The targeted learning outcomes of this session are that after this session, learners will be able to understand the concept of charged particles in matter, explore the structure of an atom, analyze Thomson's model of an atom, investigate Rutherford's model of an atom, explore Bohr's model of an atom. Dear students, you have already learnt in chapter 1 that all matter is made up of small particles called atoms. Now, we will learn about the subatomic particles inside the atom. Atoms contain protons, neutrons and electrons, which are charged particles. Now, let us talk about how these subatomic particles were discovered. Just observe the image presented on the screen. This is E. Goldstein's canal ray experiment. In 1886, E. Goldstein discovered new radiations in gas discharge and called them canal rays. These rays were positively charged. This later led to the discovery of the positively charged particles called protons in the atom. In 1900, J. Thomson discovered the presence of the negatively charged particles called electrons in the atom. So, now we know that atoms have two types of subatomic particles. They are electrons and protons. Electrons are negatively charged and protons are positively charged. The mass of an electron is 1 by 2000 the mass of a hydrogen atom. The mass of a proton is equal to the mass of a hydrogen atom and is taken as 1 unit. We have learned Dalton's atomic theory in chapter 3, which suggested that the atom was indivisible and indestructible. But the discovery of two fundamental particles, electrons and protons inside the atom, led to the failure of this aspect of Dalton's atomic theory. It was then considered necessary to know how electrons and protons are arranged within an atom. For explaining this, many scientists proposed various atomic models. Let us discuss these models one by one. Dear students, this is J. Thomson, a British physicist born in Chatham Hill, a suburb of Manchester on 18 December 1856. He was awarded the Nobel Prize in Physics in 1906 for his work on the discovery of electrons. He directed the Cavendish Laboratory at Cambridge for 35 years and 7 of his research assistants subsequently won Nobel Prizes. Thomson proposed the model of an atom to be similar to that of a Christmas pudding. The electrons in a sphere of positive charge were like currants or dry fruits in a special Christmas pudding. You can correlate this with the Indian sweet bundi ke laddu. I know you all must have enjoyed eating bundi ke laddu. It is one of my favorite sweets. Dry fruits in bundi ke laddu may be considered as electrons in the model. Thomson proposed that an atom consists of a positively charged sphere and the electrons are embedded in it. The negative and positive charges are equal in magnitude, so the atom as a whole is electrically neutral. But students, it is important to note that Thomson's model, while significant in its contributions, also had certain limitations. One key limitation was its inability to explain the results of experiments conducted by the other scientists that emerged later in the field of atomic research. Dear students, this is Ernst Rutherford, born at Spring Grove on 30th August 1871. He was known as the father of nuclear physics. He is famous for his work on radioactivity and the discovery of the nucleus of an atom with the gold foil experiment. He got the Nobel Prize in Chemistry in 1908. Here, it is interesting to note that J.J. Thomson was given Nobel Prize in Physics in year 1906, whereas Rutherford was given this in chemistry 2 years later. You must appreciate that chemistry and physics, though two separate branches of science, are very much interconnected with each other. Now, Rutherford conducted an experiment in which fast moving alpha particles were made to fall on a thin gold foil. He selected a gold foil because he wanted as thin a layer as possible. You must have read about properties of metals. Metals are malleable and ductile. Gold is very malleable and it can be hammered into very thin sheets or foils. The gold foil used by Rutherford was about 1000 atoms thick. Alpha particles are doubly charged helium ions. Since they have a mass of 4 unit mass, the fast moving alpha particles have a considerable amount of energy. It was expected that alpha particles would be deflected by the subatomic particles in the gold atoms. Since the alpha particles were much heavier than the protons, he did not expect to see large deflections. Change in path of alpha particles was observed through a fluorescent screen. But the alpha particles scattering experiment gave totally unexpected results. The following observations were made. Number 1, most of the fast moving alpha particles passed straight through the gold foil. Number 2, some of the alpha particles were deflected by the foil by small angles. Number 3, surprisingly, 1 out of every 12,000 particles appeared to rebound. So, dear students, Rutherford concluded that number 1, most of the space inside an atom is empty because most of the alpha particles passed straight through the gold foil. Number 2, the atom had a small nucleus having positive charge because some of the alpha particles having positive charge were slightly deflected by small angles. Number 3, the size of the nucleus is very small compared to the size of the atom because very few alpha particles appear to rebound and most of the positive charge and mass of the atom is in the nucleus. So, dear students, according to Rutherford's model of an atom has a positively charged nucleus at its center and most of the mass of the atom is in the nucleus. The electrons revolve around the nucleus in different orbits and the size of the nucleus is very small compared to the size of the atom. However, dear students, Rutherford's model, despite its significant contributions, had its limitations. One major limitation was related to the stability of the atom. Any charged particle moving in a circular orbit would undergo acceleration, and during acceleration it would emit energy in the form of radiation. Do you know why it will undergo acceleration? When a moving object changes either its speed or its direction, it is said to be in acceleration. Any charged particle moving in a circular orbit is continuously changing its direction and hence it has acceleration. Due to acceleration, the revolving electrons in the Rutherford model would continuously lose energy and eventually spiral into the nucleus. This scenario would make the atom highly unstable. Yet, in the reality, we observe that atoms are remarkably stable. Therefore, Rutherford's model fell short in explaining the fundamental question of how atoms maintain their stability. This led some other scientists to continue their further research in this field. Most significant of them was Niels Bohr. Dear students, this is Niels Bohr, who was born in Copenhagen on 7 October 1885. He was appointed Professor of Physics at Copenhagen University in 1916. He got the Nobel Prize for his work on the structure of the atoms in 1922. Among Professor Bohr's numerous writings, 3 appearing as books are: number 1, The Theory of Spectra and Atomic Constitution, number 2, Atomic Theory, and number 3, The Description of Nature. Now, dear students, Bohr's model of the atom is an improvement over Rutherford's model, which failed to explain the stability of atoms. Bohr proposed that number 1, an atom has a positively charged nucleus at its center and most of the mass of the atom is in the nucleus. Number 2, the electrons revolve around the nucleus in spatial orbits called discrete orbits. Number 3, while revolving in the discrete orbits, the electrons do not radiate energy. What does this mean? This means that these are not random orbits but spatial orbits which do not radiate energy when revolving, known as discrete orbits, as we discussed earlier. Now, let us look at an image of model of an atom by Niels Bohr. Here you can see the model on the screen. The first circle on the diagram indicates the first energy shell, also known as the K shell, where the electrons are allowed to revolve. The second circle indicates the L shell. Based on the number of electrons in an atom, these shells go on from K, L, M, N, etc. In the year 1932, another subatomic particle known as neutron was discovered by James Chadwick. Unlike protons and electrons, neutrons have no charge and their mass is almost equal to that of a proton. They are present in the nucleus of all atoms except hydrogen and can be represented by small n. The total mass of an atom is determined by the sum of the masses of protons and neutrons present in the nucleus. That brings us to the end of today's session. I hope you all found it very informative and engaging. Now, before we finish this topic, let's take a moment to recapitulate what we have learned today. In today's session, we covered a wide range of topics that provided us with a deeper understanding of the fascinating world of atoms and their composition. We discussed matter consists of atoms composed of charged particles. These charged particles in atoms include protons, neutrons and electrons. We also learned about the various models of an atom given by different scientists. Scientist J.J. Thomson believed that atoms were made up of positively charged material with negatively charged electrons embedded within it. According to Rutherford's model of an atom, the nucleus is surrounded by electrons that orbit it in shells or energy levels, and according to Bohr's model, only certain special orbits known as discrete orbits of electrons are allowed inside the atom, and while revolving in discrete orbit, the electrons do not radiate energy. By exploring these concepts, we have gained insights into the complex nature of atoms and the remarkable discoveries made by scientists in understanding their structure. Understanding the composition of atoms is essential because it forms the basis of our understanding of matter and the interactions that occur at the atomic level. I hope you have grasped today's topic very well. Let us check your understanding. Try to answer the following questions. Question number 1. If an atom contains one electron and one proton, will it carry any charge or not? Question 2. Who discovered the electron? Question 3. The gold foil experiment led to the discovery of dash dash dash. Take a moment to think about these questions and try to answer them based on what we discussed today. Very good. You all have understood the topic very well. Now, let's check your answers and see how well you have grasped the concepts. In response to the question number 1, if an atom contains one electron and one proton, it will indeed be electrically neutral. The negative charge of the electron balances out the positive charge of the protons, resulting in a neutral overall charge for the atom. For question number 2, J.J. Thomson is the scientist who discovered the electron. His experiments with cathode rays led to the groundbreaking realization that atom contains smaller subatomic particles. Lastly, the gold foil experiment also known as the Rutherford's experiment, played a pivotal role in discovering the nucleus of the atom by observing the scattering of alpha particles. Ernst Rutherford concluded that the atom had a small, dense, positively charged nucleus at its center. Now, my dear children, it is time to note down your assignment related to today's session. Question number 1. Compare the properties of electrons, protons and neutrons. Question number 2. What are the limitations of J.J. Thomson's model of the atom? Question number 3. What are the limitations of Rutherford's model of the atom? And question number 4. Describe Bohr's model of the atom. With this, we have now reached the conclusion of today's session. I hope you have found it engaging and informative. Thank you very much for your active participation and enthusiasm. Remember, learning is a continuous journey to keep exploring and expanding your knowledge. Wishing you all the best in your learning endeavors. Stay motivated, stay curious, and most importantly, enjoy the process of discovery. Happy learning, children.